the tricky part, or at least one of the tricky parts with this topic and this unit, is the terminology and knowing what to do when. So I'm going to be going very meticulously. If you found this quiz easy and it feels like I'm going too slow, good, but I'm going to go very meticulously. Those of you that were away, or those of you that foolishly didn't finish the quiz, don't be a meathead and just copy it out. That's not the best way to learn. You ready? Nick, what's number 1 asking me to find? Find the, and this is important, force. What's our symbol for force? You know this. What's our what letter? Okay, so we're looking at Coulomb's law. The force equation says this: F equals K Q1 Q2 over R squared, or big Q, little q if we're doing an orbital charge, but Q1 Q2 over R squared. How many charges do I have in this question? 3. What I'm going to do is I'm going to find the force. First of all, they want me to find the force on charge 3. I'm going to find the force from charge 1 on charge 3, magnitude and direction. I'm going to find the force from charge 2 on charge 3, magnitude and direction. By the way, Lena, there is also a force between charge 1 and charge 2. Don't care about that because the question didn't say add up all the forces. It said find the force on charge number 3. So this is going to be K Q1 Q3 over R between 1 and 3 squared. It's going to be 9 times 10 to the 9th. Charge 1, 2.5 microcoulombs. Mr. Dewick, shouldn't you put the negative in? Not for forces and for fields. That's why there's absolute value signs on them. Charge 3, 2.4 microcoulombs. All over, I guess 1.2 plus 0.6, I guess that's that distance, which I think is 1.8. Don't forget that. No? Yes? Okay. Here's the magnitude. It's going to be 9 times 10 to the 9th times 2.5 times 10 to the negative 6 times 2.4 times 10 to the negative 6 divided by 1.8 all squared. I get a 0.016 repeating newtons. Not a very big force. Yeah, they're pretty far apart. Is that right? 0.016 repeating? Not my final answer, so I won't round off or do sig figs yet. Newtons. I need the direction. So, which way does charge 3 feel a force because of charge 1? Is it attracted to the left or repelled to the right? How do we figure that out? We use the concept of like charges and unlike charges attract. Are these like or unlike? They are like charges. This is going to get repelled to the right. So I'll add a direction here. Right. Now I repeat. I'll change colors to make it easier. The force between charge 2 and charge 3, that's going to be K Q2 Q3 over the distance between 2 and 3 squared. It's going to be 9 times 10 to the 9th, 3.2 microcoulombs, 2.4 microcoulombs, all over 0.6 squared. Wait a minute, Mr. Dewick, let's be clever. I got most of the numbers right there. I just need to change the 2.5 to a 3.2. That's way less typing. And to a 0.6. Oh, that worked well. Do you get 0.192 for the second one? Direction. Which way would charge 3 feel a force because of this guy? They're unlike, so they'll attract. So this will feel a force in that direction. This will feel a force to the left. So what's the net force? It's going to be 0.192 take away 0.016 repeating. Winner minus loser. If they were in the same direction, Maddie, I would go winner plus winner. So it's going to be that minus 0.01. I'm just going to do a bunch of sixes. That should be pretty good. 0.175 newtons. Direction, read. By the way, instead of right and left, you could use east and west, but I didn't see a compass rose. I didn't bother putting one, so I used left and right. If you got that, 7 out of 7. Otherwise, I would probably give you something like this. I would give you 1 mark for that, 1 mark for the numbers, 1 mark for that answer. I didn't want to erase that. Specifically, I would give you a half mark for the magnitude and a half mark for the direction. I would give you 1 mark for that, 1 mark for the numbers, half mark for the magnitude, half mark for the direction, and then 1 mark for your final answer. Okay? That's a good example of what I can do with multiple charges and forces. I could also have them at right angles and make you add them tip to tail. I'm not going to do that on this test, but for what it's worth, that's also doable. I'm not going to do that on the test. Sarah, what's your question? You sure? You good? Okay. What else could I do? Well, if I give you 2 or 3 charges, here only 2, I could ask you to find the overlapping electric field. So, we're sitting at location A right there. We want to find the electric field. Now, I know the word field begins with an F, but Nick, what letter does what does the letter F stand for in physics? You already told me. So don't be going like this. The most common mistake that drives me cray-cray is kids do this and they find the force between them. What's our brief for electric field? Well, E for electric. So it's going to be capital E equals, I have 2 versions of electric field. I'm going to use the one with the R in it. So I'm going to find the electric field from charge 1, which is going to be Q1 over R1 squared. I'm also going to find the electric field from charge 2, which is Q2 over R2 squared. While we're talking about electric fields, remember then the electric field hockey game will be due for Friday for the day of your test as well. Okay? Electric field is a vector, so I'm going to find both magnitude and direction. The magnitude is going to be 9 times 10 to the 9th, not negative, 5 microcoulombs, all over 1.5, don't forget the squared. 9 times 10 to the 9th times 5 microcoulombs divided by 1.5. I got a typo, don't I? Divided by 1.5. Don't forget the squared. And I get a nice even 20,000. What are the units for electric field? It's newtons per coulomb. Gravitational field was newtons per kilogram. Direction. How do we figure out the direction of the electric field? We pretend this charge doesn't exist. We pretend right at point A there's a positive test charge. A tiny positive test charge. How tiny, Lily? So tiny it doesn't have its own electric field, because that would change the question. And we ask, which way would a positive sitting right there want to move because of Q1? Quinn, which way would a positive sitting right there want to move because of Q1? Would it be attracted left or repelled right? And it's kind of a complicated directional procedure. We had to define a direction because, unlike gravity, stuff can fall up. So gravity was obvious, the gravitational field toward the center of the planet. Here, well, no, we better come up with a rule. 9 times 10 to the 9th, 3 microcoulombs divided by 0.85 squared. This won't work out evenly. Why did I use 0.85? That's a yucky number. I'm going to be lazy. I can backspace and edit. By the way, hopefully you figured out this trick, that a lot of this you can backspace and just change a couple of numbers. Instead of a 5, it's going to be a 3, and it's going to be a 0.85. Don't forget the squared, Mr. Dewick. Did you get 33,370 and change? What was it, Mr. Dewick? 37,000. 370 newtons per coulomb. Direction, which way would a positive sitting right there want to move because of this guy? I think also left. It would be repelled. How will I add left plus left, left and left? Will I go winner minus loser? Nope. So the net electric field is going to be 20,000 plus 37,370. I can do that one in my head. It's going to be 57,000. I'll round to there, 400 newtons per coulomb left. 57,370 if you went that far. Okay. If you got that, 7 out of 7. Otherwise, I would go 1 mark for the equation, 1 mark for the numbers, half mark for the magnitude, half mark for the direction, 1 mark for the equation, 1 mark for the numbers, half mark for the magnitude, half mark for the direction, and then 1 mark for the answer. Half mark for the magnitude, half mark for the direction, probably. Okay. That was the easiest amount of typing. Now it gets a bit uglier. We can do this. Cohen, what are they asking me to find in example 3? So I'm going to go straight to work equals the change in potential plus the change in kinetic. I think I told you we can assume that I don't see a speed mentioned anywhere here. Okay? So it's just going to be the change in potential. What's change in anything? So the work is going to be K Q1 Q2 over R final, not R squared. R squared is force, minus K Q1 Q2 over R initial. Work. Oh, we're starting from an extremely large distance away. What am I trying to hint when I say an extremely large distance away? We're starting all the way out where, Lily? Why does that make this question easier, not tougher? And it's initial. If we ended up at infinity, I would cancel out the final. But here we're starting at infinity. I can do that because we've defined 0 to be out at infinity. That made this question a lot less, no pun intended, work. I would have no problem on the test not starting out at infinity and giving you an initial radius and having you have to calculate both. I think that's also fair game. So this is going to be K 9 times 10 to the 9th. Q1, we put, do I put in the negative? Or don't I? How do I know? I didn't put absolute value signs on there. Okay. Negative 8, was it microcoulombs again? I think it was. Yeah. Q2, they didn't give me Q2. It's an electron. Negative 1.6 times 10 to the negative 19. Okay? If you leave that blank, or if you, I don't know it, it's on your formula sheet. Also the mass of an electron if there's a question that involves mass. Here it's just that, and our final was 0.15. Nine times 10 to the 9th times negative 8 times 10 to the negative 6 times 1.6. No, negative 1.6, Mr. Dewick. Divided by 0.15. Check for typos. I think I'm good. You get 7.68 times 10 to the negative 14. Doesn't take much work to move an electron. Also, we really didn't get it that close to the negative charge. What was it, Mr. Dewick? It was units, joules, direction. Direction. That's a scalar. Yep, just messing with you, okay? Hey, Mr. Dewick, let's even do this because we can. Oh. We'll stick that there. So you got the calculations. If you got that, 7 out of 7. This one, I gotta be honest, to me is a little easy for 7 marks. I'm thinking now on the test, I'm not going to have this term be 0. But let's talk a little bit about this. Did we, Lena, get a positive answer or a negative answer? Does that make sense? Would the electron want to move towards that negative charge, or would you have to push it? You would have to do work. You should get a positive answer. Yeah, absolutely. You would be having to push and push. The closer you got, the harder you needed to push. So it would take even more work to move it closer, and very rapidly the work would get bigger and bigger because the force would get bigger and bigger as well. Last one. Example 4. Ooh. Mallory, what are they asking me to find in example 4? Do they say speed or velocity? That already suggests maybe hint some kind of a scalar approach. What am I going to do for this one? Conservation of energy. Did this question say how much work? So every so often I'll see a student write W equal, no. It doesn't say how much work. This is conservation of energy, G. So it's going to start out as K E initial plus P E initial. You know what? I think I forgot to give out the part marks here, didn't I? 1, 2, 3, 4 lines, Duick. I would probably do something like this. 1 mark for that, 1 mark if you crossed that out, 1 mark for that, 1 mark if you crossed that out, 1 mark for that, and then maybe 2 marks for the answer. I don't know. A little too easy. Back to here. KE initial plus PE initial equals KE final plus PE final. Do you need to memorize this equation? The reason I'm saying that is I've seen this written wrong on tests by some students, which means either they're dredging it from memory or they're thinking, it's going to be a final minus it. It's not a change in. It's not a change in. It's right from your formula sheet. It's the law of conservation of energy. The amount of energy you begin with has to be the same as the amount of energy you end with. Energy is conserved. Are any of these 0? Hey, the proton is initially at rest. Mallory, what am I trying to find? Which of the 3 remaining terms contains within it the final speed? I'm eventually going to get this term by itself, but you know what? Let's do the substitution. It's going to be K Q1 Q2 over R initial, no squared, equals a half little m V initial squared plus K Q1 Q2 over R final, no squared. I think what I'm going to do first is move this to that side. Oh, V final, thank you. Really, I could have just done that and now I'm covered, but yeah, I hear you. It's going to be K Q1 Q2 over R initial minus K Q1 Q2 over R final. That equals a half little m V, you're right, final squared. Alrighty. K, 9 times 10 to the, that's a terrible 9, Mr. Duick. Q1, 5.5, and it's going to be positive. Mr. Duick, put the 5.5 there. Times 10 to the negative 6. Q2, it's a proton. No! Who said negative? It's a proton. Positive. 1.6 times 10 to the negative 19. Again, the proton and the electron, they have the same magnitude of charge. That's why we called it the elementary charge. That's a mass. Don't be telling me kilograms or coulombs. Okay? R initial 1, I think. Minus same thing, same thing times same thing times same thing divided by R final. This drives me crazy. I see kids do that. Is R final 2.5? 3.5. I did that on purpose because there's one like that in your future. Hint, hint. And the number of kids that write 2.5 drives me crazy. It's going to be 3.5. That equals a half mvf squared. All right. 9 times 10 to the 9th times 5.5 times 10 to negative 6. It's a proton. 1.6 times 10 to negative 19. I'm going to write the divided by 1. I know I don't need to, but I'm going to go backspace and stick it in for the second term anyways. But don't be yelling at me, Mr. Dewick's dividing by 1 on his calculator. I know. Is the first term 7.92 times 10 to negative 15? No? Yes? Minus... this is going to be a yucky decimal. 2.2628, I'll go 2.263 times 10 to negative 50. 2.263. That equals a half m. You figured out the difference between the elementary charge and mass? Yes? Okay, that's important. Let's combine this as one number. 7.92, scientific notation button, negative 15, minus, answer button. On the left, I get 5.657 times 10 to negative 15. 5.657 times 10 to the negative 15. That equals a half mv final squared. Now what? How would I get the v by itself? How will I move the m over? How will I move the 2 over? And I'll ignore the 1. Okay, so it's going to be this. 2 times 5.657 times 10 to the negative 15 divided by m. It's a proton. Good. That's when I'm going to use the mass. When it's, a mass. What is it? 1.67? And it's going to be the square root of that mess. That equals VF. So 2 times answer button divided by 1.67 scientific notation negative 27. That's faster than light. Oh, square root. Had myself worried for a second there. Or I'd won a Nobel Prize. 2.60 times 10 to the 1, 2, 3, 4, 5, 6. Okay. If you got that right, 7 out of 7. Otherwise, I would give you 1 mark if I saw that line, 1 mark if I saw that line. I would probably give you 1 mark if I saw that line. That's 3. I would give you 1 mark for that number, 1 mark for that number. That's 5. I would give you 1 mark if I saw that, and 1 mark if I saw that. Can you give yourself a lovely score, please, out of 28? Any lawyering with me, now is the time.